Right, in this video, in our design sketching series, we're going to talk about circles. And by extension, that probably means we're going to be talking about curves as well. Now remember, my approach to design sketching is what's called the box method, sometimes called the crate method, but it's a theory that says that most complex objects in the world can be drawn in 3D after you construct them out of boxes. But as you and I both know, things in the real world are not box shaped. They are curvy, and they're circular, and they're elliptical, and they're oval. So we have to start to try and figure out how we go about drawing and sketching circles and curves. You can do this tutorial with a pencil. That's all you need for now. My camera doesn't pick up a pencil line so well, so instead I'm using a Bic biro. So the one thing that you need to know about a circle as a designer who's doing some sketching is that a circle fits inside a square. A circle fits exactly inside a square. Just like that. Once you understand that principle, and once you can draw them and construct a circle inside a square, then you can draw circles in all kinds of 3D shapes. And I'll show you what I mean. So, a designer approaches a circle by first of all drawing, as well as they can, a decent square. I can see already that this is more of a rectangle than a square, but it doesn't matter. And this is where we start to make use of all those extra lines that I've been advocating when you're sketching. Using the diagonals to find the center point, putting in a horizontal and a vertical divider. Now this is all construction. This is not, in the end we want a circle, we don't want all this stuff. So this is light lines, this is all just construction and practice. Now a circle, I want to introduce the 4 points of a circle. A circle touches the edge of the square there, 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 and there. 4 points. So a circle touches 4 points. And it's those points that are marked off by the horizontal and the vertical dividers. Now between those points, it's your job as a sketcher to try and smoothly join them up. This is one point where you should absolutely turn the page. Not the best circle in the world, that's because I started off with a shape which was rectangular rather than square, but nonetheless, the point remains that the circle has to touch the square in these 4 points. Also, you'll notice that the circle crosses, see this diagonal right here? The circle crosses the diagonal about 2/3 of the way up the diagonal. So 2/3 of the way towards the edge of the square is where the circle crosses. So imagine that diagonal divided in 3, and it crosses roughly 2/3 of the way up. It's not exactly 2/3, but it's good enough for us. That's how you build a circle. Let's practice that again. Let's try and get a good square. Better square this time. Let's put our diagonals in. And a horizontal and vertical. Way around, a vertical and horizontal. Now we know that the circle touches those 4 points at the top of the cross and at the side of the cross. So let's draw in beautiful curves. Let's start off and end at those points on the square. And also hit that 2/3 mark. So there's 1/3 and 2/3 along that way. Difficult to do, let's do it again. Copy it with me. Start off with a square. Let's put in our diagonals and our vertical, and our horizontal. Now let's try and draw it. Oh my goodness, that's the worst one yet, but we'll fix it by darkening up our favourite lines. So that we get a circle inside a square. Now, that is mega important, okay? A circle fits inside a square. Now, I'm not going to write the word square down here. I'm going to write the word quad. New word. A circle fits inside a quad. A circle fits exactly inside any four-sided shape. So the problem comes that when we're drawing in 3D, when we draw as in 1 or 2 point perspective or as an isometric, faces which we intend to be square sometimes end up being distorted. So for example, if we drew an isometric cube, which as you know has got an edge down there and lines going back at 30 degrees, we know that a cube in real life is built out of square faces, like a dice, like a box, but on paper these faces are not square. They still have four sides, so they're still quads, but they're no longer square. But that doesn't matter because we put in our construction lines. We go from corner to corner, that gives us the centre, and from the centre we put in a vertical and we put in a horizontal, which has to be at 30 degrees because those are the only angles we're allowed. And we look for the 4 points that the circle touches. That's there, 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 and there. And we look for the 2/3 up the diagonal, which is there and there. Divide that diagonal into 3. And it's the exact same process. You now have to draw a line which beautifully touches the very edges of the square, but also cuts through that 2/3 mark. A circle fits inside a quad. There's our quad. 1, 2, 3, 4. Constructed and bisected, as we did with the normal square. And now we fit a circle inside it. Let's do it for the top face. Let's put a cross in. Find the centre point. From the centre point, especially in isometric, we're only allowed lines to go at 30 degrees. So again, let's look for the 4 points that it's going to touch. And our 2/3 up the diagonal mark, let's put little ticks in just to help us. 2/3 along the diagonal. I find these curves are the easiest to draw first, the longer curves, the shallower curves. And then we have to come in and join them up. Like this. Okay, not the neatest one in the world, but well, we can fix that. If you're using pencil and you make as much of a pig's ear of that as I did, you can rub it out. Let's go for the side face now. I'm going to change colour so we don't get confused with this arrow. It's constructing our 2 diagonals. Our vertical coming down, meeting the centre point, and our line going across like this. We're only allowed 30-degree lines, so let's look. So it crosses there and there, and 2/3 along that line. So let's put in an elegant curve there and there. Now I'm not going to be too fast to darken this time. Try and get this a little bit neater. And there. Practice a couple of times, get the muscle memory going, and in there. And that is how, there's the main point there. A circle fits inside a quad. So it doesn't matter what type of 3D projection you're trying to do, isometric, perspective, or what have you. So long as you can build a quad in that world, then we can put a circle inside it. Let me show you some examples of that. So let's build a 3D, let's build a 1-point perspective box. Let's put in a horizon line and our single vanishing point. Let's put a box up here. Remember, with 1-point perspective, we start off by drawing the front face. There's our square. Find the center. Build our square properly. Now let's project that back. Decide where the back of this is. The back of it's going to be there. That bit has to be projected back as well. So 2 faces at the front and at the back. Now let's go in and decide. Let's work on the back first of all. The circle touches the tops of the cross and 2/3 through the diagonal. That's what we'd see at the front, at the back. Turn the page. Now let's join those 2 circles up. And we're starting to see how my theory or my idea is going to bear out that all world objects, especially the complexy curvy ones, can be constructed out of squares and boxes. So, in 1-point perspective, by taking a circle drawn inside a square and projecting it back to another circle drawn at a faraway square, we've in actual fact made a cylinder. Let's try a 2-point perspective drawing. Let's put a vanishing point there and a vanishing point there, and build in an edge. Construct our box again. Let's construct our cube, just as we did before. Now we're going to draw a circle on the top here. In fact, we'll do one on the side as well, just like we did with isometric. So, in perspective again, there's our quad. We've spotted our quad. We can put a circle inside it. Okay. Now from this point, we've found our centre point by doing the diagonals. From this point, we can draw straight up and down. But from this point, it has to project back to the vanishing point. And there's our circle construction kit right inside there. We know that the circle's going to touch there, 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 and there. And we also know if we divide our diagonals into 2/3, around 2/3, then we know that our circle is going to pass through approximately those places too. And that's how we construct a circle in 2-point perspective. Now, let's look at this original sheet again. I want to show you something else here. Let's say you didn't start with a square. Let's say you started with a rectangle. And again, this time, let's put in our diagonals to find the centre of the rectangle, and from the centre, project a line up and project a line out the way. Now, by going 2/3, 2/3, like that, Now by doing this, because we have elongated the square, what we're in effect going to do is draw an ellipse, an elongated circle. So perhaps we need to modify our definition again. And instead of saying circle, we say an ellipse fits inside a quad. Practice that. Practice the construction of a rectangle or a square and a circle or an ellipse inside it that touches at the top, bottom and 2/3 along the diagonals before we move on.